Welcome back, students. This lesson will be focusing on approaches to learning. I would encourage you to read your text so you could get some more information on what this topic what we will be discussing today. We can study learning indirectly, making observations and measurements of what changes in behavior. So we know that psychology is something that is quite well complex somewhat in that um, we need to try to figure out what people may be thinking, but then in order to do so, psychologists would have to study the behaviors that they perform to determine what they are thinking. So learning is something that happens in the head, so we need to study, we can't study learning indirectly. Learning, of course, could be studied in a natural environment, which yields a lot of, good and rich information. And that is where you put yourself in wherever the subject that you are trying to study, you would put yourself in the environment that they are in. If it's an animal you're trying to study, you go out in the field wherever they are. If you're trying to study a baby, you go wherever the baby is, and so on. Thus, naturalistic observation as a method has been extensively used to study learning, both in animals and in human beings, because to understand something in its natural setting clearly provides information that you will not be able to get otherwise. Now, detailed observation of any phenomena, say classroom learning, leads to classification of various elements of that phenomena. So when you observe it, you could decide, put it in categories. Example, classroom learning can be classified into verbal, perceptual, motor, as well as problem-solving categories. So we could learn, and there are different categories of it. But like anything else, there are advantages and disadvantages of naturalistic observation. Let's talk about the main advantage. It is a very important step to study any phenomena, and that includes learning, because if we're trying to figure out what makes or what environment is best for a baby to learn in, then go wherever the baby is. You don't have to manipulate the baby. Just, you just get a great sense of what is happening with the baby by looking at the baby in its natural setting. But of course, there are disadvantages, and is complex and difficult to do, because if you think about baby and trying to understand a baby, you know how a baby is unpredictable. How do you put the baby in the right position for you to hear what is happening or see what is happening? You may miss something. So as much as it would be nice to see a baby in its natural setting, we know that to create or to understand any phenomenon in its natural setting can be quite complex, because you cannot manipulate and put yourself in that position that you want to yield the best results or answers, right? Classified phenomena, when closely scrutinized, may lose distinction among subcategories. So when we try to categorize it and scrutinize it, you may lose a distinction among those subcategories. And another disadvantage is that it's uncontrollable. As I indicated earlier, the baby, you cannot control when the baby cries, or if the baby, you can't control if the baby cries or urinates or whatever it is. You really cannot do that. You cannot control when they do it. You just need to be prepared when the behavior occurs to be able to observe it and to be able to take notes accordingly. In recent times, the study of learning has come under more systematic control and objective method of scientific inquiry. Now, we know that scientific method is quite useful in trying to understand or to study anything. And in psychology, it is used quite widely. So here we have seen an experiment being performed. You could see a mouse or a rat and trying to get some food, and that is something that you probably would be familiar with by now. Now, science seeks to generate confirmable propositions by fitting a formal set of symbols, which is language, mathematics, logic, to empirical observations. Hidden in this definition are two important philosophical positions of rationalism and empiricism. Combine these two positions create a powerful discipline of inquiry. The scientific method captures the empirical side of science and has many advantages. And let's talk about them. One, very productive. Think about when you do an experiment, you know that you have decided how you're going to do it, you have tried to put the right environment for you to conduct the experiment. So you know at the end of the experiment, you would have yielded results or data that is rich and you would have not wasted your time. So using that method is quite productive. You can't control the variables, obviously, therefore, as I indicated when I used the example of the baby, you could decide when the baby cries, or you could decide what temperature the room is in or what the baby is in, decide when the baby feeds, and all of those various things, and that makes it very important and an advantage. Repeatable. If you do an experiment, unlike if you were to just observe a baby in its natural setting, you could decide to do it over and over, because sometimes when you observe once, you may have missed something. There may be some extraneous variables that may be impacting negatively on your ability to observe properly at a particular point. But then if you repeat that experiment, you could probably see what you may have missed if it was a natural setting. So that is an advantage. Unambiguous. The results that you yield would be clear. Whatever is there, it's quite clear, and that is an advantage. It is objective. And what does it mean to be objective? If something is objective, it means that you do not put your feelings in it. And so therefore, that is a positive, because it's not what you feel, but what exactly is there, what's in front of you, what has been found. The disadvantages, on the other hand, is that at times it cannot be used for ethical reasons. So if you go back to the baby example, the example with the baby, you would know that it is unethical to take a baby and decide that I'm going to increase the temperature of the room to an extremely unbearable temperature to see if the baby learns better in cold or warm environment. That is just unethical to do. And because you find that when you do an experiment, the variables that you use, and whatever results that you get, it will be based on that particular group of or whatever. For example, how would I say? If you say you're trying to study a baby of African descent, you know that you cannot decide that I'm going to generalize this to all babies because you only use babies of African descent. So yeah, it's difficult to generalize. All right? So a theory based on science is a system, and think about a system, different parts, of interrelated hypotheses that explain a number of observations or phenomena. Here are some aspects of a theory. A theory has two aspects, one based on rationalism and the other on empiricism. Formal aspects of a theory include words and symbols that explain observations. And then we have the empirical aspect of a theory comprised of physical events and observations that are measured and quantified. Drive reduction theory, let's spend some time there. You may have heard about it before. Hull, you know that one group will be looking at Hull extensively during the semester, so I'm not going to spend much time on it, but at least I will introduce you to it. So let's suppose we have a theory. It states that all learning depends on drive reduction. All learning. To develop the validity of this theory, it needs to be tested rigorously with experimentation. So you really have to do this thing, you have make sure all of your T's are crossed, all of your I's are dotted. You rigorously test it to see indeed whether every learning in several types of learning will depend on drive reduction, because you want to test it. So how do we develop a theory? Although theories may be based on observations, they more likely begin with them. Yeah? So theories begin with observations. They may be based on observations, but they begin with them. Theories mature, therefore, through experimentations. Drive reduction theory. In experiment 1, what happened? A thirsty pigeon learns to peck at light to get water. That's the first experiment. In the second one, a hungry rat learns to press a lever to get food. So look at what the theory says. Experimental results lead to formal aspects of the theory, right? So look at this graph here. So we would see that the level of arousal, yeah, and quality of performance. So you increase the drive reduction theory, increase learning, but there's an optimum level, however, you would see here, yeah. So if the level of arousal is low, then the quality of performance, it's really poor right here. Person may be sleeping, then your person is boredom right here, mild alertness, but then you have, when it's at the optimum level, right, the performance is at its highest level of arousal. But then if a person is too aroused, the person can become stressed, anxiety could set in, and the person could panic if the level of arousal is too high. So that is what drive reduction is trying to bring across to us. To the scientific law, what drive reduction theory is saying is that the greater the drive reduction, which is in turn is called reinforcement, the higher the learning in an animal. That's what they're saying. That's the proposition. The formula, therefore, look at the sign before the dr. So drive reduction, the higher the drive reduction, the higher the learning, may eventually become a law. Eventually, that is, if the relationship between the two events are held consistently. So if I repeat that experiment over and over and over, and every time I perform that experiment, what would happen? I would realize that the greater the drive reduction, the greater the learning, then I could say, well, yes, this is a law, right? This is true. In the end, research evidence, data, which empirical aspects, feed a theory, which is the formal aspect. And theory, in turn, proposes new predictions that need to be confirmed with data. So theory, in turn, proposes new predictions that need to be confirmed with data. So theory brings about new positions, and new predictions, proposes new predictions that need to be conformed with data. Now, although the relationship between empirical and formal aspects of theory is complex, generally the two are connected with logical reasoning, right? So here it is. So here we see we do research, we use data in research, and data now, theories come out of data. We use the data to create theories, and we have hypotheses, and these in turn we use them in research. So in our drive reduction theory, if the drive reduction theory holds, then a hungry cat can learn to escape a puzzle if rewarded with food. Because remember we said the higher the drive reduction, the higher the learning, right? So falsification of a theory, let's talk about that. Intuitively, we may realize that not all forms of learning can be based on drive reduction. Any experimental rejection would weaken the theory. It would hold true if every time that is done, you get the same results, right? One can imagine that the formal aspect of a theory can make sense in themselves, but can make erroneous predictions about the physical world. So if experimental evidence suggests that animals can learn without drive reduction, our theory therefore is in jeopardy. All right, so this is about a hypothesis. Predictions or hypotheses generated by theories are testable statements that propose a causal relationship between manipulated and measured variables. So again, we see hypotheses. Predictions or hypotheses generated by theories are testable statements. They are testable, that propose a causal relationship, cause and effect, between manipulated and measured variables, right? So we'll come to an end now. That's part 1 of our discussion, and we will continue for another with the lecture in a part 2. So again, I hope you take some time to review this and read up on it. Bye.